Graph the following function. All right, so we have this function f of x is equal to 1/2 x squared minus 3x minus 1. And they ask us to actually do 5 things, right? Find the vertex, the axis of symmetry, the intercepts, domain and range, and then where the function is increasing and decreasing. All right, so to do the first part where it says 1/2 x squared minus 3x minus 1, in order to get its vertex, we could, of course, complete the square on the function to get it into that structure that allows us to see the vertex. So let's go ahead and do that just for good practice, because it's something that you might have difficulty doing when you have a coefficient that's a fraction out in front. So let's go ahead and work with that. So we have f of x is equal to, remember this trick is to put the x's together, right? And then kind of leave a little space where the constant is, and then put parentheses around the parts with the x's, right? All right, now factor out the leading coefficient of 1/2. And remember, when you do that, you end up with x squared, and then you have to divide the 3 by 1/2. Let's just do that over to the side. What happens if you take -3 over 1 and divide by 1/2? Well, remember, the rule is that you flip and multiply, so that's like multiplying by 2 over 1, right? When you divide fractions, you flip the second fraction and you multiply. So it's simply going to give you -6, which you could probably do in your head a little bit to think, how many times does a half go into 3? Well, it goes in there 6 times, right? So minus 6x. Open up the parenthesis, then you have -1. All right, good. From here now, what we want to do is complete the square. And the completing the square step isn't too bad here. We'll have half of -6 squared. Now, half of -6, of course, is -3, and you square that and you get 9. So we'll be adding 9 here, and don't forget that what we're really adding there, because of the 1/2, is we're really adding a positive 9/2 to the function. So we have to subtract off 9/2 on the other side. That makes sure that it cancels out to 0. All right, from there we'll go ahead and factor. So basically we can do this one pretty easy. What factors of 9 add to 6? That'd be 3 and 3, and it needs to be negative because the middle term is negative. So x minus 3 is the answer there for that. And then if you write 1 as 2 over 2, we'll end up having -11/2 when we combine these two numbers together. So -1 and -9/2 make -11/2, right? Because 1 is 2 over 2. Okay, good. So we have that. We have the function in the form that allows us to see the vertex. All right, so the answer to the first part of the problem is to say that the vertex is +3, -11/2. So we have that first answer. Again, remember, it's the opposite sign here for the x-coordinate, and then the same sign for the y-coordinate. That's why it's +3, -11/2. All right, then they ask us for the axis of symmetry, right? Well, the axis of symmetry, we can draw this, but I can just tell you that the axis of symmetry is basically the place where you have the vertical line that corresponds to x equals h. So this is the axis of symmetry. So remember, that's x equals h generically, right? X equals h. So in this case, x is equal to 3. So in our case, we have 3 for the x-coordinate of our vertex. So x equals h is the axis of symmetry. When we graph it, we'll show why that's the case. But before we graph it, let's go ahead and get the intercepts for the function to do part C. To do the intercepts, we're basically going to be looking at plugging in 0 for x, right? In order to find the y-intercept, right? So what I'm going to do is create a little grid here. And let's find the y-intercept. That's the easiest one to find. Let's go back to the original function. It's actually easiest there. The first two terms will cancel out, just leaving you a -1, right? So you put 0 in for 1/2 x squared, you get 0. Put 0 in for 3x, you get 0. And you just have -1. So we have at that point the y-intercept. That's the easy one, right? To get the other ones, we have to set y equal to 0, and we'll get 2 x-intercepts. So what happens if we set y equal to 0 in the original function? So we have 0 is equal to 1/2 x squared minus 3x minus 1. So we have to solve this quadratic equation. And to solve the quadratic, we're basically going to first check to see if we could factor it. That's actually not going to be factorable though, so we're just going to jump right to the quadratic formula to say that x will be equal to -b, so that's going to be +3 plus or minus the square root of the b term squared. That'll be 9 minus 4 times the a term times the c term. And then from there, we'll divide everything by 2 times the a term, so that's 2 times 1/2. All right, so we've done this so many times, and just to speed it up, I'll tell you the answer works out to be, there are 2 different answers here. We end up with -0.317, and I'm kind of using decimals here because we're going to graph these, and so it's easier if we just have them that way. And the other one would be 6.317, so 6.3 0.317. All right, so if you want to just, have the decimal answers to make it easier to graph, there they are. You could actually leave them as fractions as well, but just to know where they are on our grid, those are the solutions for the intercepts. So we end up with two answers, minus 0.317 and 6.317. Okay, so for our intercepts, we'll basically say that we have 0, comma, -1, and then minus 0.317, comma, 0. And lastly, 6.317, comma, 0. All right, so there's the intercepts. All right, let's do the domain and range then. To do the domain and range, I'd like to take the information we've done so far and actually graph the function. The reason why I want to graph it is you can then see the domain and range visually. All right, and then from there, we're going to go ahead and plot the points that we have. So the vertex is basically at 3 on the x-axis. So 1, 2, 3 on the x-axis. And then we're going to go down 5.5 on the y-axis. So 1, 2, 3, 4, 5, 6. So 5.5 is about there. So that's our vertex. Now the parabola will open up, but it's going to be a little wider than normal. To make sure we get these points right, let's plot the intercepts. So 0, -1 is one of the intercepts. So that would be right here. That's the y-intercept. And then we have like minus 0.37. So kind of right after that, it's going to hit the x-axis there, that's just above where our y-intercept occurs. And then we have 6.317. So if we go out to 4, 5, 6, and 7, it's between 6 and 7, a little closer to 6. So maybe that's about there. And then we plot it, and there's basically what our parabola will look like, right? So we got 4 points there. That's good enough to get the general shape. We know it opens up because the 1/2 is positive, and that's essentially what it looks like. So that's very good, but keep in mind that we have to answer the domain and range question now. So we can certainly see from the function itself that it doesn't have any square roots. It doesn't have any situation where we'd worry about the function becoming undefined because we don't have a rational expression here where we have an x in the denominator, anything like that. We don't have anything else that would cause issues. Later on, you'll see there are some other things that could have some issues regarding the domain, but we don't have any of that here. So basically, without a radical and without a fraction that has a variable in the denominator of the fraction, we can pretty much say that the domain is all real numbers. So that's easy enough. The domain is basically going to be from -infinity to +infinity, meaning that you can put any x value you want into the function. There's no restrictions. All right, but for the range, it's a little bit different. For the range, we actually see that there are no y values below this point, right? So below this point here, there are no y values. And the reason why there are no y values is because that's the minimum value of the function, right? The vertex is the minimum in this case. So the question is, where is the lowest y value? Well, we actually have that to be the vertex. So that'd be at -11/2 on the y-axis, right? So that's as low as this function goes, and yet it goes up forever, it seems, right? It shoots up forever, and that's definitely true, so it'll go up to +infinity. So the range, in other words, the y values that result from the given x values are going to go from a minimum of -11/2, which we include because that's actually a point on the graph, and then all the way up to infinity. Okay, so we have the domain and range, so we've answered part D. And then we just have to answer, where is it increasing and where is it decreasing? Well, let's remind ourselves of that axis of symmetry, which we said occurs at x equals 3, right? So at 3 here, right, we have this kind of dividing point between the two sides. And that's actually also the dividing point between the increasing and decreasing intervals. If you were on this riding it, say it was like a roller coaster and you were on a little car riding this down, left to right, generally speaking, you'd be going downhill here, right? Until you hit that minimum point, and then you'd start to go back uphill. So it's decreasing from -infinity. So let's write the decreasing one first. It decreases from -infinity all the way up on the x-axis until you get to where x equals 3, where our axis of symmetry is, right? So at x equals 3, basically, you hit the minimum. And at that point, it stops. So we basically have decreasing from -infinity to 3, but then it picks up and starts to increase from that point on. From 3 on the x-axis, it's going to increase. So from 3 to +infinity is the increasing part of it. And so that's the answer for that last piece of the question. Again, if you were on like a little roller coaster, if this was a ramp, as you move left to right, generally in that direction, you'd be going downhill until you hit x equals 3, and then you'd start to go uphill. And so that's our increasing and decreasing intervals.